In this exercise, we use the epsilon delta definition of the limit of a function to show that the limit of the fraction 2x plus 7 all over 4 as x approaches 2 is 11 over 4. Before we get started with the proof, let us review the definition of the limit of a function. We take a function f of x equals y, which is defined on an open interval containing x equals a, except possibly at x equals a itself. We say that the limit of f of x as x approaches a is the value L if and only if for every positive epsilon there exists a positive delta such that the absolute value of f of x minus L is less than epsilon if or whenever 0 is less than the absolute value of x minus a, which in turn is less than delta. We use this notation to indicate that the limit of f of x as x approaches a is L. For the exercise, the function f of x equals y is given by f of x equals 2x plus 7 all over 4. The value a is given by 2 since x approaches 2 in the exercise. The limit L is 11 over 4. The definition mentions a positive number epsilon and a positive number delta. Whatever positive value of epsilon we choose, we should be able to find a positive delta such that if the absolute value of x minus a is between 0 and delta, then the absolute value of f of x minus L should be less than epsilon. The focus of the proof will be on the absolute value inequalities. Even though the definition states that if the absolute value of x minus a is between 0 and delta, the conclusion is that the absolute value of f of x minus L is less than epsilon, we start with the conclusion. We start with the absolute value of f of x minus L is less than epsilon. And so we start with the absolute value of 2x plus 7 all over 4 minus 11 over 4 is less than epsilon. Our main objective is to show the existence of a positive delta. Our objective is to form the absolute value of x minus a, or the absolute value of x minus 2 is less than delta. We do not work with the 0 in the delta inequality because the 0 in the delta inequality is just to remind ourselves that x is not equal to a when x approaches a. The first part of this exercise is to show the existence of delta. We can achieve this by finding delta in terms of epsilon. We simplify the starting inequality and we have that the absolute value of 2x minus 4 all over 4 is less than epsilon. We divide everything inside the absolute value by 2. And so we get that the absolute value of x minus 2 is less than twice epsilon. We compare this inequality to the inequality that we have in our objective. Matching corresponding parts, we see that we can set delta to be equal to 2 epsilon. To complete the exercise, we now need to show that if the absolute value of x minus 2 is less than twice epsilon, then the absolute value of 2x plus 7 all over 4 minus 11 over 4 is less than epsilon. In doing so, we are making the conclusion in the definition rightfully the conclusion. This should be a simple task because all we have to do now is to reverse the steps that we used in finding delta in terms of epsilon. Let us suppose that the absolute value of x minus 2 is less than delta, which is equal to 2 epsilon. We multiply the entire inequality by 2, and then divide everything by 4. We get the absolute value of 2x minus 4 all over 4 is less than epsilon. Inside the absolute value, 2x minus 4 all over 4 is equal to 2x plus 7 all over 4 minus 11 over 4. Therefore, we have shown that the absolute value of f of x minus L is less than epsilon whenever x minus a or x minus 2 in the absolute value is less than delta. This completes the exercise.